Hello everyone, welcome to my channel. In this video I would like to look at the integral of cosec x dx by using z-substitution. I promised in the previous video that I was going to come up with another video that explains how you evaluate this integral by using z-substitution. So I want to do that in this video. So this is how we approach it. The integral of cosec x dx by using z-substitution. So it goes as follows. The starting point is we say let tan, remember we are dealing with x here, so we're going to take x over 2 be equal to z. Now what does this mean? Let's look at the right angle triangle where we define this angle x over 2, right angle triangle, and this is our angle x over 2. And if tangent of this one is z, we know that this is z over 1 basically, and so that means the opposite side over the adjacent side. By Pythagoras theorem, you'll agree with me that the hypotenuse is just 1 plus z squared, and we take square root of that. Now there are three results that I want to obtain from this one here, two of which may not be used here, but one of them will be used here. And in the next videos that I will bring up on z-substitution, I want to just make reference to them. So let's go into the three, how we derive them. The first one is to remember that sine of x using double angle formula, this is twice sine of x over 2 times cosine of x over 2. Now using this triangle here, you'll agree with me that this is just 2 times sine of x is supposed to be opposite side over hypotenuse side, so z all over square root of 1 plus z squared times cosine is adjacent of hypotenuse, so that's 1 over square root of 1 plus z squared. Simplifying this, it gives us the following result, which is very serious. Sine of x is equal to 2z all over, you multiply those two, the answer is just 1 plus z squared. So this is result number 1, very critical when it comes to z substitution. I want to move on straight to result number 2, basically talking about cosine. So let's look at cosine then. Again, using double angle formula, cosine of x using double angle formula is equal to twice cos square of x over 2 minus 1. Remember double angle formula for cosine. This is what we get. Let me just clean up this a little bit here. Right. So that's what we get. Now, so we perform substitution then. This is going to be 2. Remember cosine of x over 2, cosine of that angle is going to be 1 over square root of 1 plus z squared. So this is going to be 1 over square root of 1 plus z squared. We have to square the whole of this expression and then subtract 1. Taking us to page 2, we want to just simplify that. Taking us to page 2, let me move this one down. Right, taking us to page 2, what are we saying? We're basically saying that that expression gives us 2 times 1 over 1 plus z squared, and we're saying minus 1. Remember, when you square 1, the answer is 1. When you square, the square root of 1 plus z squared is just 1 plus z squared. Now simplifying this, you agree with me that this is 2 all over 1 plus z squared minus 1 plus z squared all over 1 plus z squared. Now, this is 1, obviously. You can see that these two can cancel to give us 1, but I want to make the denominator the same. So this is going to be 1 plus z squared. And what are we saying? In the numerator, we have 2 minus 1 plus z squared in brackets. Removing brackets, we're getting something like this. 2 minus 1 minus z squared all over 1 plus z squared. And so that takes us to another very important result. Cosine of x is just equal to 2 minus 1 is 1. So 1 minus z squared all over 1 plus z squared. So this is a serious result number 2. We have one more to go. The transition from dx to dz. Remember, we want to move from the variable x to variable z, from variable x to variable z. So we have to look at the transition now. So taking us back to where we started from, we remember we started from tan of x over 2. This was equal to z right at the start there on page 1. If you can see it here, there, I want to differentiate both sides. Derivative of tangent is secant. So what we're saying is sec derivative of tangent is secant squared, not secant. Sec squared x over 2, remember chain rule, we multiply by the derivative of x over 2, which is just 1 over 2. And then we say dx. And this is just going to be equal to dz. And multiplying by 2 both sides, remember this is one angle. So what we have now is sec squared of x over 2 dx will be equal to 2 dz. Now this, going back into the triangle, what is sec of x over 2? It will be the hypotenuse over adjacent side. Remember definition of secant, but it has to be squared. So taking us to page 3, what we have now on page 3 is, hope you can see it, yeah, what we have now on page 3 is we're basically saying that what we have now is square root of 1 plus z squared all over 1. That's secant of x over 2 squared. We're saying secant squared of x over 2 is this expression here. I have to square that. And then I have dx. This is equal to 2 dz. Now simplifying this, you'll agree with me that the answer is just 1 plus z squared in brackets dx. And this is equal to 2 dz. Taking us to another very critical result, which is dx is equal to 2 over 1 plus z squared dz. That's the transition. So these are the 3 very critical expressions for z-substitution. Look at the first one. We said the first one is this here. Sine x equals 2z over 1 plus z squared. That's the first one. Hopefully you can see it here. You can. The second one is this expression here. Cos x is equal to 1 minus z squared over 1 plus z squared. And the last one is a transition, that one. Now we can go back to our integral. We can now go back here and say that this integral actually simplifies to, remember, let me just remind you right on the outset that this is actually the integral of 1 over sine x dx. That's why we're interested in this, because we have sine there. Remember, cosecant is the reciprocal of sine. Okay, so now going back to this integral here, we're going to say, therefore, the integral of 1 over sine x dx changes to the integral of 1 all over, what is sine x? Well, sine x is this expression here, 2z over 1 plus z squared. So 2z over 1 plus z squared. And then what is dx? Well, there is dx times 2 over 1 plus z squared dz. Now, this one here, you agree with me that this is just the integral of 1 plus z squared over 2z times 2 over 1 plus z squared. If I put these in brackets, you can agree with me that these cancel, and the 2 cancels that 2 there. We have dz here. So we have 1 over z dz. So this is equal to the integral of 1 over z dz. Now you agree with me, if you have watched my previous videos, the integral of 1 over z is just the natural log of z. Taking us to page 4. So basically we are saying now that this integral here changes to the natural log of z plus obviously c, because we're dealing with an indefinite integral. But let's go back to page 1. What is z equal to? Going back to page 1, here we go. Z is actually equal to tan of x over 2. So we're just changing this back to our original variable. This is natural log of tan of x over 2. And then we are saying like this plus c. So this is the final solution. So what are we saying basically? We are saying the integral of cosec, let me write it here. Therefore, the integral of cosec x dx is basically equal to natural log of the tan of x over 2, if you like in brackets, absolute value there, plus a constant c. So this expression here, this integral has many expressions. You saw one expression in the previous video. This is the second expression for the same integral. Right, in this video, I'm going to stop here, but this is just introduction to z-substitution. Two more videos are prepared already, and I want to, two more questions are already prepared, and I want to discuss one of them in probably the next or so of the videos that I'm gonna bring up. All right. If you're new to this channel, please support us by subscribing and inviting friends to subscribe, sharing these videos, and your comments are extremely important. So provide us with your comments. What do you think about what we produce on this channel in terms of quality, and maybe what are your aspirations and what are the things that you want us to discuss? All right, we'll see you in the next one.